Hi there, and welcome to Lesson 10.4 on radical equations. The goal today is to be able to solve a radical equation. Let's get started. We're going to start with an investigation. So here I have a list of quite a few of the perfect squares, all the way up to the square root of 225, and I just want you to take a look at the answers to each one of those. They're all rational numbers, right? But do you see any square roots that are equal to a negative number in this list? No. Now think about when you've taken the square root of other numbers that maybe you get an irrational answer with, like the square root of 60 or the square root of 19 or the square root of 150. Are any of those equal to a negative number? No. The answer is no to that. Is it even possible for the square root of something to be equal to negative 5? Well, maybe you're thinking right now, well, maybe it is. What if I were to take the square root of negative 25? Would that be equal to negative 5? Well, try it on your calculator. If you type in the square root of negative 25, your calculator is going to tell you error. Actually, try typing the square root of any negative number. That's not going to work. It is not possible for a square root of anything to be equal to a negative number. That's really important to note. The square root cannot be equal to a negative number. When you take the square root of any number, it's always going to be a positive. Okay, with that being said, let's go ahead and start solving some radical equations. All right, we're going to solve, and then we're also going to check our solution. So let's look at number 1. The square root of x is equal to 12. The goal here is to come up with the value of x. Now, you're probably thinking already that you know the answer to this. You probably do. You know that the square root of 144 is equal to positive 12. And you're right. So looking at this, x should equal 144. But how do I algebraically get that? And that's what we want to be able to do, is to show our work. So I need to take the x out of the square root. I need to get it out of that cage. So I think, what's the opposite of a square root? Well, that would be squaring a number. So if I square this side, that radical will cancel, and I have to also square the other side. Knowing that a square root and squaring a number are opposites, that x is going to be left alone and isolated. Then over here on this side, 12, here I'm going to put this in parentheses, 12 to the second power here, I get 144. So the value of x is 144. So algebraically, I was able to solve that. Okay, let's try another one. Over here on this side, we have the square root of x minus 7 is equal to 9. All right, so let's algebraically solve this as well. The goal is to isolate the x and get it all by itself to find the value of it. Well, right now the x is trapped in this radical sign. It's trapped in this cage. I'm going to leave it there. I'm going to undo the minus 7 first. So kind of think like this is our acquaintances, right? We're going to send them home first. So we're going to add 7 to both sides. So on the left, I have radical x. And over on the right, I've got 9 plus 7, which is 16. Okay, so now I've got to get this x out of the radicals. Trapped in there, I have to do the opposite of taking the square root, which would be squaring a number. So I'm going to square this side and the other side. Whatever you do to one side, you do to the other. That's going to cancel, leaving the x by itself. Then over here, I've got 16 to the second power, which is 16 times 16, or 256. So let's go back, and we're just going to plug that back into the original equation, and we're going to see if that, oh goodness, come on, I want to change it to black. Oh, there we go. We're going to see if this worked out. So here I got the square root, and instead of the x here, my answer is 256. And then minus 7 equals 9. So the square root of 256, that's a perfect square. That's 16. So if I take 16 minus 7, does it equal 9? And yes, it does. It checks out. So my answer is true. Let's try number 3. All right, on 3, our goal is to get the x. We're going to start by solving the equation. Oops, I wanted red. I don't know what happened to red. There we go. Red. Okay, so let's start by undoing this plus 6. We're going to minus 6 to both sides. And I have radical x equals 0 minus 6 is negative 6. Okay, now remember, we said that the square root cannot equal a negative number. So right here at this point, you need to recognize that you've isolated the x, the square root. We've isolated the radical, and it's saying it's equal to a negative number. And we just got done saying that this cannot be true. So at this point, as soon as you isolate that radical and it says it's equal to a negative number, our answer is going to be no solution. Now I want to show you why. Let's put no solution in our notes. Now this is why. Well, trying to change the color. There we go. Okay, I'm going to pretend like I didn't notice that. So I'm just going to keep this going here. All right, so to get the x out of the radical, I would square it, and I do the same thing to this side. I have to square this entire side. So I'm going to put this parentheses around here. The entire side needs to be squared. So let's cancel that. I get x equals, and then negative 6 to the second power. Negative 6 times negative 6 is 36. Okay, so let's now go back and plug this in here. If I plug in a 36, under this radical, the square root of 36 is 6, and 6 plus 6 does not equal 0. Now let's just say that you didn't put the parentheses around here. Let's just scribble those out. Let's pretend you didn't even do that, and you did negative 6 squared. That would give you negative 36. Now let's put that back underneath the radical. Try typing in the square root of negative 36. Your calculator is going to say error because you can't take the square root of a negative number. So no matter what, if you try solving this, whatever answer you plug back in is not going to work. So this is no solution. And as soon as you get that radical isolated and it says it's equal to a negative number, at that point you stop, no solution. Okay, let's try this next one. Looks a little crazy and complicated, right? Let's put the line down the middle here. Well, I meant for that to be blue. That doesn't want to change. It says, nope, I'm not going to be blue today. Oh, there we go. I figured it out. Oops. Boy, my struggles. Okay, here's blue. All right, the goal is to get the m isolated by itself. Right now, both sides of this equation are trapped in a radical sign. They're trapped in a cage. So I have to undo that so I can get the expressions that are under the radicals to come out. So the opposite of squaring a number is to take that number and square it. So cancel, cancel. And this expression will now come out. 3m minus 6. Over here, cancel, cancel. I can now remove the expression out of the radical. Okay, if you remember solving equations where you have a variable on both sides, here we have 3m and here we have 1m. We want to go to the bigger side, so we're going to take away m, minus the m, and minus the m. 3m minus m would give me 2m. Okay, now we'll add the 6 and home acquaintances here. 2m equals 29. Well, clearly 29 is not divisible by 2, so we're going to end up with a decimal, which is perfectly fine. And 29 divided by 2 is 14 and a half. All right, so we end up getting 14.5 for a solution. Well, I just want to check that solution, and it's always a good idea to check your answers, okay, because you could have ended up with a no solution somewhere along the way. So if I plug in to m here and m here on both sides, if I plug in 14.5, so here's 3 times m, which would be 3 times 14.5, take away 6 equals, and over here, if I replace the m with a 14.5 plus 23. Now, if I just evaluate this with my calculator, if I take 3 times 14.5 minus 6, that's going to give me 37.5. And over here, if I take 14.5 plus 23, I get 37.5. And so I can see that both sides are in fact equal. Whatever the square root of 37.5 is, they're both going to be that answer. So just by plugging that 14.5 solution back into the original equation, I can see that yes, it does make it true. kind of that, a lot of work, extra step checking it. But a lot of times students will miss the fact that there's no solution, and it's always a good idea to go back and check your answer. That way you can catch that if there's a mistake. Okay, whoop. Oh, we got to go back. All right, on 5. Let's get ready to solve. So I'm going to draw the line down here. My goal is to get the x by itself. Now you see how 4x is kind of trapped under the radical? We're going to leave that there. We're going to undo the times 7. So this is kind of like our acquaintances over here. We're going to remove that first outside the radical. So we're going to divide by 7. Divide by 7. Okay, so now I have radical 4x is equal to 6. So do you see how I've isolated the square root in this step? And I see that the square root is equal to a positive number. We're good to go. Let's continue. Let's get this 4x outside. Let's get it from being trapped under the radical. So to get rid of the radical, I have to do the opposite, which is squaring it to both sides. So cancel that. 4x is out of the cage. 6 squared is 36. I'm going to keep it going, dividing by 4. And I get x equals 9. Okay, so let's just double check your answer for a moment here, just to be sure that we didn't make any mistakes. So I'm going to put the 9 back up into the equation. So I got 7, and under the radical, this would be 4 times x, which is 4 times 9, and then that equals 42. Okay, well, this radical, 4 times 9, is really the square root of 36, because 4 times 9 is 36. And we know that the square root of 36 is just 6. So if we take 7 and multiply it by 6, it does equal 42. Yes, we've checked it. Always a good idea to check that.